Hi, everybody. Welcome to the first day of PDC. My name is Dragos Manolescu. I'm a program manager in Live Labs. Live Labs is a group chartered with advancing the state-of-the-art in internet technologies, and it's comprising engineers and researchers alike. And today, I'll be talking to you about mashup security. Many of you probably understand that Web 2.0, though we may not agree what exactly means, has brought us a lot of interesting innovations. And probably on your top 5 list, you have mashups. Mashups represent the ability of putting up together interesting experiences using bits and content that others have toiled on and have worked hard to create. For example, imagine the ability of putting a map, an interactive map, on a website. Or imagine the ability of putting a side meter on a website. That's great, right? Interesting experiences, interaction, compelling for the users. Well, not so fast, because mashups are actually relying on assumptions that no longer hold. They're using the Web 1.0 security model, and that's causing problems. So let me give you a quick example. Here's a typical site that you're all used to. You see you have content from various providers, and deep down in there, there's bit of JavaScript that allows the owners of the site to track usage. And I understand you cannot probably see it here, but let me blow it up for you. And this is the offending code, if you will. Now, I want to emphasize that I'm not picking on this particular site. This is the state of the industry currently, and they're not doing anything wrong. Everybody's using the same patterns. And what's wrong with that? Well, you see that they're extending the trust to a third party. Their site is going to be as secure as their content is, as well as all the content they're pulling together from other sites. Same thing for the quality of service. Same thing for the user experience. When sites go down, when the third-party sites go down, so does theirs. And as a matter of fact, that has happened not too long ago. So this is a situation that we want to address. And today, I am pleased to announce to you the Live Labs Web Sandbox, a technology preview. And to best understand how we got into this situation, how we are dealing with these problems right now, I have with me here Scott Isaacs, the creator of DHTML, and I'm going to pass it on to him.
Hi, my name is Scott Isaacs. I work for the Windows Live Experience team, the organization that owns Hotmail and a lot of our web properties. I've been involved in the web probably basically since the beginning. In the mid-90s, I was responsible for helping define the initial DHTML specifications, wrote the 2D positioning spec, and helped define a lot of the standards that we basically rely on today. What is interesting is I'm going to give a very oversimplified history of web development, because I could probably spend 2 hours on this, and people that know me know I have done that before. But the technology that we're all relying on today actually dates back to the mid-90s. We all discuss AJAX, Web 2.0, and all these neat new technologies. We say the word terms REST, but when you go look underneath the hoods, you're going to discover that not much really has changed. It's just the patterns that we rely on. Let's think about mashups, which is this great new concept. At least we claim it's this great new concept. Mashups actually have been with us all along. In the mid-90s, we had the first tick counters. Before you even could put one line of code on your page, you used to drop these images on your page that would tell you how many people visited you. That was the first mashup. Not a very powerful one, but first nonetheless. Things quickly evolved. Amazon and a bunch of commerce companies realized that affiliate programs, when scripts were introduced, they could extend to the long tail of the web via these affiliate programs. So you would drop a script on your page, sharing the transactions, and so on with some various partners. The biggest affiliate network that basically serves as a foundation for many of the business models is advertising. Advertising, again, relies on the same technology. What was interesting to happen in the past few years is with the Web 2.0 mashup, I call this low-cost innovation. The idea that you go visit a real estate site, I'm just going to pick a random example, and for a real estate site to be truly compelling, they wanted to present a map of where the house was located. Well, prior to Web 2.0, that real estate site would probably have sat down and said, geez, how hard would it be to build a mapping service? How much would it cost to go acquire all that data, and so on? Well, what happened? A bunch of major companies, Microsoft, Yahoo, Google, we all invested and paid the large costs for providing a scalable service that anyone on the web can rely on. So Maps basically started driving this basically aggregated revolution around people getting low-cost innovation for basically, well, you call it free innovation. They got to leverage these services for nothing. What's happening really recently is that sites are even going one step further. They don't want to just consume information. They want to provide information out. iLike has a really interesting platform. iLike is a service, I'll explain it in one sentence, is they basically let you to get playlists, and they allow people to aggregate and share playlists and rate playlists for music. They want to let other sites participate with their data and their experience by dropping the script on other sites. So not only are sites wanting to consume, but they want to push things out. As you saw in the SiteMeter case, is that it's a very big problem. Mashing up third-party content creates this environment that is very challenging, not only for the site, but for the users. First off, think about this. When you build a site, let's just pick Maps because they're the most common, that includes a mapping script. Or think of the SiteMeter example we started with. You made an explicit decision to include a script from a third party. Well, the way the web works today is that third-party script is loading into the context of your domain. So implicitly, you never state this outright, but implicitly you've just extended not only the security of your site, but the privacy policies and the robustness of your experience to not only you, but every one of those scripts you've chosen to include. Now, in the case of Maps, I call that tightly coupled mashups. The idea that you made an explicit decision, I'm just going to trust that. But as we start opening up the platform more, things get a lot more blurry. A lot of sites want to start exposing gadgets, or the idea that any third party could extend your experience. So how do you do that in a really reasonable way? Well, what does this mean for the user on the other hand? Users have no clue any of this is happening, nor should they. They're visiting your site, expecting a really rich experience, and you're delivering one. What they don't realize is that they're at the whim of not only you, but all the partners that are, all that site's partners that they've chosen to interact with. This creates a very challenging environment where your site's only as reliable as the weakest link. We did a little bit of pre-disclosure on this. Our snake, otherwise known as Robert Hansen, I've discovered everyone in the security industry has a neat little alias. When we were discussing this with him, he looked at this and said, geez, you guys are working on one of the most damaging problems we face in the browser on the web today. It's, again, as we said in the beginning, this is the way the web works. This is the way the web has worked since the beginning. But it's time for some change. So what is the state of the art? Before today, there was not much you could do. The first and most obvious is what I call you put your blinders on, you ignore the problem, you ship your site, and you hope for the best. That's basically what we're all doing when we're including third-party scripts. You iframe the problem. This one is a cause for some interesting debate. A lot of people look at iframes as the security solution for protecting content. Iframes are actually all about isolation and a little bit about security. Iframes protect that untrusted code from interacting with your personal information on your site. Just to be explicitly clear, when that script from SiteMeter was included on Gizmodo, if that script changed, it could have accessed everything on that page. If the user was logged in, it could have accessed user information. It could have communicated back to Gizmodo's server. In the case of an iframe, it would not be able to interact with the page. It would not be able to interact back with that server, but it could still try to do lots of bad things. It could try to redirect you to a phishing site. It could try to install an extension in your machine. It could do history interrogation, and we'll come back to that one later. And the latest one that's been coming up is it can try to perform clickjacking. I'm not going to go into clickjacking. You could go search the web and read a lot about it. This problem is not unique. There's been a first-generation solution which Facebook has worked on, which is called Facebook.js, was a new programming model to allow people to codify how they can interact with the page. The key thing here is, though, Facebook introduced a new programming model. And what we wanted to try to do was say, how do we do this without a new model? And last, which is the most important, think back to that SiteMeter example. That wasn't a security issue. It was a quality of service issue. So how do you do this and address the quality of service? So where do we need to go with this? We're going to give a ton of demos, and this is almost like the last of about 6 slides we're going to have, and the rest of this talk is almost going to be demos, is right now we're presenting everything in the context of a gadget. They're more visual. They're easy for you to look at and understand. But we believe the long-term direction is to think outside of that box, literally and figuratively. Today, a gadget is typically a region on your page. Something carves out a rectangle on your page, And that rectangle is going to provide some interesting experience and probably hooks to the outer environment. There's no reason that we should be stuck in that box. That box is actually driven a lot by the fact that we're in this iframe model. What we really want to get to a point is where a site can provide APIs on the client that any third party could come in and interact with, and we want to do it securely. The other thing is we keep talking about third-party extensibility. Well, if you build a proper web, application, forget the web, you typically want to build components. Well, you want to also probably build components that cannot make a mess of other things on the page or interact poorly. So this security model, as it evolves, can also solve your first-party development. You can make sure that one component on your page cannot destabilize or be used to exploit the rest of your site. Rich advertising, well, you get more APIs, get more integration. Clearly, we could get more advertising opportunities. So the key things here are we have to control the trust model and protect the overall experience. So what is this opportunity? It's really to secure the Web 2.0 model. Evolve that technology base that's been around for the last 15 years and figure out how to address it as we move forward. This is not something that Microsoft is looking at uniquely. We are not the only ones that are looking at this space. It's pretty much a pretty apparent problem to everyone that's trying to develop technology. The ECMA working group, for those of you who aren't familiar, is the working group that owns the JavaScript standard. They set up a separate subgroup to focus on web security. All the usual suspects are involved. Us at Microsoft, Google, Yahoo, IBM, Facebook, some of the open source libraries. If I omitted you and you're part of it, I'm sorry, but it's a pretty large group here. There's a bunch of other technologies that are being invested in. Yahoo, Douglas Crockford, who I believe is also at this conference, he's a great person to talk to, works at Yahoo, worked on something called AdSafe, which was a dialect of JavaScript. Google has this project called Kaha about securing things. Together, we are all trying to work together to define a standard. What you're going to see now is our approach on how we not only view this as a security issue, but how do we solve the broader problems around programming models, robustness, as well as security. So give us a moment just to wire over to this machine. One thing that you will notice is that we are going to use probably a different browser for every one of our demos. We'll probably be the only talk that will start with Chrome as our first demo. But we're just going to fire up in Chrome. And the reason we do this is we want to make it very clear that this technology is browser agnostic. It runs in every modern browser. And when you think about it, that's a very important point, especially when you're looking at security. So let me just make sure. OK, good. So what we're going to do here is make a very simple clock gadget. What you're looking at is an HTML page. You'll notice we start with an HTML tag. We have our script block that's going to create a clock when I click, and we have a body. Let's remove the old one. And I'm going to run it in the sandbox. That's the message. I'm just going to click. And you'll notice when I click, a clock started. Just to show you what executed, we set the title to be a new date, just a simple little timer. This should be familiar to any JavaScript programmer. Now, a few things that I want to point out with this demo. First off, no iframes have been used. And the only way I could easily illustrate this is show you that I could select through it into the outer page. So what we're using here is a concept that we call content transclusion if you're from the HTML space. But it's basically we're including this HTML document directly into the context of the other page. But the sandbox does much more. It's going to actually do this in isolation. So really quick, I'm going to quickly clone this and create another clock, and it's going to run. It's the exact same code is now running twice on the page. There is no interactions. I could select between them to try to illustrate again that we have no iframes. Now, developers will quickly point out and say, well, wait a minute. There's a lot of ways things can collide, and I'm just going to remove those to keep the page simple. And we're going to just quickly set the color on this. Color white. And we're going to create one, and you'll notice I get that. And we're going to tweak the colors again. Whoops. And we're going to get another one. Now, most time when I show this to people, they start jumping up and down. Wait, what's going on? That's an HTML page. I don't know any way you can load that thing directly into another web page and have it run securely. Well, there's a bunch of black magic, as you can imagine, going on underneath the hoods. So kind of to quickly drill in, and we'll reemphasize these points later. I just want to walk you through the beginning. There's the original untrusted input. This is the code that some third-party person wrote. When we hit that run in Sandbox, we sent that code via a transformation process. JavaScript is a dynamic language. This transformation process has nothing to do with security per se. What it does is take that code that came in and outputs that code in a way that we can virtualize into a scoped environment. So what actually got output from that code is this a very interesting JavaScript function. And that JavaScript function, I'm not going to walk through the code explicitly, but that JavaScript function basically gets instantiated inside the page, via another script that is basically going to manage that processing execution. It's going to ensure that every line of code that runs stays isolated. The last point I want to just show real quick is, this time I'm going to generate an error. Now think back to that site meter example. In that site meter example, something errored and it brought down the entire page. One of the big problems that you have when you build mashups is that you're at the whim of the third-party code. And the other problem with the browser is it has this one single thread that everything is executing on. So if there's ever an error on the page, your entire page may come down. It can cause all execution to stop. Now, let me just click to make sure we have a clock running. We got that clock running. I'm going to quickly throw an error. And we're going to throw an error by just me typing some random stuff. Try to run a random function that doesn't exist. When I click on this, you'll notice that the capability was disabled. I'll admit our error message is a little geeky. We'll work on error message text, but let's just look at what happened here. I tried to invoke something unsupported. This method doesn't exist. But the key thing to notice is the clock kept ticking. If this error occurred on most web pages, something else on the page would fail. In this case, we were able to disable just the offending code and keep execution running.
All right, thanks, Scott. Just to be absolutely clear with everybody, in the previous demo, as well as in all the other demos that we will be doing today, we're not using iframes at all. Not at all. So what happened? The boxes that Scott has shown in the browser are actually part of this bigger picture. On the top left-hand side, you have untrusted code that you can either enter in the text box or read from a URL. And this is the untrusted content we want to run within our page. We're pushing this untrusted content through a transformation pipeline that transforms the code from the original CSS, HTML, JavaScript into trusted JavaScript. And then we have our sandbox that is going to fire up and create instances of these functions. So that's how you get multiple instances of the same page running together. Scott has already mentioned some of the challenges that we have to deal with when tackling this problem. And quickly, to summarize, first off, we're dealing with JavaScript. JavaScript is a dynamically typed language, which means that at build time, we cannot really verify anything about security. We cannot even verify that the program works. Also, it has a shared global namespace, which leads to interesting collusions between various libraries that developers tend to include, and has a single thread where everything has to run together. In addition, we have a DHTML, and the browser has the shared presentation model, which means that if I have a gadget running side by side in my web application that shows my account balance, the gadget could reach out to the DOM and pull my account number and send it to a third party. And we also have CSS, and the C in CSS is causing all the problems in that I could get a property that may destabilize the site cascaded to me. There are also challenges about the browser. Browsers don't use the same extensibility mechanism. So if we are to build this as a browser extension, we'd have to build a different extension for various different browsers, and that's not really an option. Plus, would you really want to go with security as an option to your browser rather than something that's built in? Think of your ATM cards, for example. Is the PIN optional, or does it come with the card? You may have heard, anybody here has been at the keynote earlier? Okay. So one of the themes that you heard there is that we want to use, you heard Ray talk about it, you had Bob talk about it, you had Amitabh talk about it. We want to use the tools and the languages and the libraries and the whole development stack they already have. And we looked at this book written by Pip Coburn, and he has assembled a set of use cases and scenarios where he evaluated various technologies like LCD displays and satellite radio and ISDN. And he boils down the success of a technology to the ratio between the customer pain, which is what the technology is addressing, divided by the total pain of adoption, of what's going to cost you to adopt the new technology. And in our case, we know what the customer pain is. We showed you the example with side meter. We talked about some of other examples. And we want to actually minimize the pain of adoption. We want to use only the materials in the room to help you solve these problems. In other words, typically, when you write programs, division by 0 is an error. In our case, division by 0 is a goal. And I'm going to ask Scott to elaborate a little more about what we mean about using just the materials in the room to solve the security problem.
So, really quick story. I don't know if it was 1 PDC ago or 2, but I was on stage presenting Windows Live Web Gadgets. Internally, as part of my job in Windows Live Experience, we came up with this very interesting model for how people could extend our portal pages and Windows Live Spaces with their own third-party code. The model that we proposed, that I basically put together, I built this whole architectural framework, and the model that we put forth basically required you to use this pretty complex library. We had these things called bindings that use CSS selectors to attach things, and it was a pretty complex. It had this big SDK that we didn't even document as well as we would have liked, and so on. What was interesting was, within a week after announcing, the first gadget that was created was what I call the iframe gadget. Everyone said, geez, I don't want to learn all that really rich stuff unless I really, really have to. Instead, I figured out how to put an iframe in my gadget that's going to point directly to my site, and I'm going to write my stuff in HTML, just the way I understand and just the way I would love to do it. Now, another observation I had was Google, around the same time, a little bit after, introduced their own web gadgets. And they also had a set of APIs and libraries that you could use. And the first gadget I saw that was created there was the iframe gadget again. The community was telling us something. There was a set of great development patterns that already existed, and it wasn't our place to try to replace them. Rather, it was how do we embrace those patterns and allow people to leverage libraries as a value add, not as the way that they actually have to define the programs. So as we go through this, you'll notice that all our demos are going to be standard HTML pages. We're starting from simple HTML. Now, in the beginning, I made the comment about collisions. Today, the way collisions are typically addressed with third-party libraries is via agreement to follow a pattern. It's not an enforceable agreement. And I'll give an example. I assume a lot of people in here have used open source libraries before. The $ is this predominant pattern for how you get a shortcut to get an element by ID. Almost every single library out there has exposed their own $ function. And one of the first things that happened was once people decided they wanted to combine framework A with framework B and framework C, the $ functions started clobbering each other. The last one won, and things started breaking. The other interesting scenario that came up was that people wanted to extend base prototypes of objects in JavaScript. So the object prototype in JavaScript is the object everything is derived from. And third-party libraries wanted to add a method or property to that object. The moment they did that, every for-in loop that did not follow a defensive programming pattern failed. Just because one library out there added a property to an object. Clearly, that is a pretty bad thing. So what we're going to show you now is a little bit of isolation. We're going to start back with the clock again. In this case, I moved the clock out to a function called doClock. Now, this is kind of an esoteric pattern. I don't love it, but it's going to make the point. When we do the click, I'm going to call doClock, and then I'm going to blow it away. So that function is no longer going to exist for the next time I click. And we're going to quickly run that clock. Let me remove the existing instances. We were testing it earlier.
And this is Mozilla, by the way.
And now we're in Mozilla. We're going to work our way through the whole browser stack. We will get to IE eventually. When I click, we got the clock. When I click again, nothing's changing. Actually, I forgot. I actually put a message. The clock is running. Because what happened was the doClock function doesn't exist anymore. Now,
Scott, where does that message appear?
The message is appearing below. Now, what's interesting is you'll notice I set the default status on the window. and I did not change the window of the actual outer page. Our security system was able to intercept that assignment and offer the host environment its own choice. In this case, the host environment decides the status is going to appear below the gadget and titles are going to appear above it. You'll notice the title of the page has never changed. I'm going to quickly clone this guy. We're going to clone him 2 more times. And I'm going to click, and the clock is going to start up again. And if this was not in a sandbox, the fact that that do clock function was destroyed by the previous code, we would not get a clock here. But since we're in isolation, we keep getting unique clocks. Now, the last thing I want to point out, because this kind of comes up a lot, is we're going to quickly just illustrate this, foobar. IDs is another source of potential collisions. Again, the only way this can be covered today is via agreement that you follow a pattern. You can't enforce it. So if a third-party script puts an element on your page with the ID that already exists, they will break any code that tries to get that element. So to illustrate this, we're just going to do this quite quick and simple. We're just going to go. I'm just going to do this one from style sheets. We're going to make a red one. And you'll notice I'm not going to change the ID, and now we're going to make a blue one. And you'll notice that they're each retaining the correct style and appearance. And to re-emphasize, no iframes are anywhere in here. If I could find this, I could select through it. Now, one of the more interesting examples, which I brought up, was the object prototype. Prototypes are a cause of a large number of collisions in the language. Every library and every sophisticated JavaScript developer wants to extend the prototypes of objects. So what I'm going to illustrate here, using a very simple illustration, is that we can keep prototypes completely in isolation. And we can also use the esoteric patterns that JavaScript has. I mean, these are pretty interesting operations. The to uppercase method is built on the date. I'm sorry, it's built into the string. And we're going to take that implementation and add it to the date. So what's going to happen here, some remnants from before, I'm going to run this, and when I click, I'm screaming the date at you. The date's in all uppercase.
I don't like that, Scott. Make it lowercase. I don't want you to scream at me.
Well, a lot of people have this aversion, and let's say I want to make sure, I'm one of those guys, I mean, I think it's the head of Yahoo sends all his emails in lowercase. He might have functions like this built in. But what I want to do is if anyone tries to make things uppercase, I'm going to force it to be lowercase now. So you'll notice I'm again going to be calling the to uppercase call. So now you're going to get what you expect. The date is all lowercase.
What about the other instance?
But if I go back to the other instance, you'll notice it retained its reference. So you're able to do this, again, without any collision or conflict. Moving on. One of the interesting things here is everything I'm showing you is focusing on that security aspect. The other interesting thing is just to point out, like when the security area was first starting to be examined, the general agreement was that we had to focus on a few good parts of JavaScript. How do we protect JavaScript or change the language to secure it? Well, as I learned when we did the web gadgets, that the community as a whole, all you developers in the room, have a set of knowledge and expertise that you want to bring to the table. It's not my place to tell you the good or bad parts. Douglas Crockford has this book called JavaScript: The Good Parts. People always ask me for a good book recommendation. There's one. But it focuses on a lot of great aspects of the language. I like to say is I'm trying to embrace everything. I don't know what's good or bad. You're going to write your code the way you're going to write it. It's our job to secure it. Beyond security, we go focus on what I call the processing model. The multi-instancing. You saw a few instances where I was hitting that clone button. The guy that wrote that code just had no clue that he could be cloned. He didn't even know he was getting put in a sandbox. He just wrote a web page, and it just got dropped into another page and ran just fine. Code throttling. Just put that one aside, and I'll show that in a few minutes, and quality service monitoring. So as I said, we spend more times in demos than we're going to do anything else. Give me a moment. I think this is where we go to IE. Is this grad school? Yep. Nope. Graduation. We gave our demos weird titles. Graduation. All right. Perfect. One of the big things that we wanted to emphasize was leveraging the knowledge and expertise you have. But we wanted to go a step further. One of the biggest challenges web developers have is handling the browser differences. Most of us use libraries at this point to abstract them, and those libraries are doing a bunch of funky work underneath the hoods. We are running, I'm not sure if I'm running IE7 or IE8 here. I think we're running IE7. We're running IE7 here. This could have been IE6, 7, or 8. But there's something interesting about this code. I don't know if people in the audience will figure this out, but add event listener, I'm just going to keep going because we're going to run tight on time. It's normally going to query you guys. But the key point here is that add event listener is a W3C event model. IE supports the attach-detach event model. It's the model that I introduced in DHTML back in '95. IE is capable of supporting the latest W3C APIs. It just isn't built in yet. Well, for developers, that means you have to basically, before this, write your code or use a library that would handle those differences. We no longer have to worry about it. So this code is pretty straightforward. It's going to hook the event listener of the click event. It's inside there, we're going to then do something else interesting. We call getComputedStyle. If you're familiar with how to program the standards, IE's way of getting the current calculated style is the current style property. Another one of those IE-isms that's been around for 9, 10 years. The W3C pushed a model with getComputedStyle and getPropertyValue.
What about the event properties?
All the event properties and everything that you're familiar with will also work. But just to run this, remember, we're in IE. The click event properly fired. The calculated styles are getting properly returned. So what you're seeing here is that we can actually normalize the programming models across the browsers. We can do more than just provide security. We could give you a consistent way of dealing with your code. And this is not just about fixing some standards. There's 2 events that have been in IE. I'll just give an example, onMouseEnter and onMouseLeave. I think they're very useful events that just haven't made their way in the standards yet. We've made a decision, we've added those events in the other direction. They're in all other browsers. So we can use the whole security system to not only normalize it, but we can use it to experiment with new APIs and so on.
Scott, what does this mean for developers who are used to writing browser detection code?
Well, what's interesting is, I don't have the demo here, but Facebook has this animation library. And when we dropped it into our sandbox, all the code paths that went down the standard path, the one that was commented in their code that kind of said the Firefox and other path, it never even entered the IE code path. It stayed in the W3C standard path and ran just fine. So in theory, inside the sandbox, that library could eliminate all that level of cross-browser code. Now, so far, our model is focused on internal to the page. Well, you're going to want to write gadgets that can interrogate outside of that box. Again, we could have invented a new programming model, but we chose not to. Iframes actually provide a programming methodology and pattern that is familiar. So remember, we are not in an iframe. But as a web developer, you can consider your code to be in one. So looking here, you'll notice that I'm going to hook the onDoubleClick event of the outer page. Now I want to make a few points about this. I set a property on the body of the whole page. If the outer page had its own event handler, or if another piece of code tried to set this property, you don't have to worry. You are setting only you've got your own version of that property that you set. You will never override or collide with anything in the outer page. And that's explicit and it's a necessary guarantee. So in this case, I'm going to double click, and you'll notice that I double clicked on a body element. The reason it said body, I'm sorry, there we go, the P element, because I'm inside my own emulated synthesized iframe. Your code doesn't know it got dropped in another page. When I double click out here, it told me I double clicked on the text area. Now this is interesting. We've made the decision, and I could be corrected if people think this is wrong. The tag name actually is not a security issue. Reading a tag name of a built-in W3C standard tag, not custom tags, cannot leak information. So what that they double-clicked on a text area? Let's try to read something a little more dangerous. We're going to try to read the inner HTML this time. I'm going to remove the other one. When I double-click inside my code, there's nothing wrong. You're reading information you put on the page. Nothing to worry about there. Now, think back to what we said in the beginning. With mashups, code have access to a shared presentation tier. Normally, they could read everything else on the page. In this case, no, it failed. He was not permitted to read information outside of their control. And that's extremely important. Now you're noticing I'm letting you read hook events. There's information on that event which is safe and information that's unsafe. Imagine a key event. You should not be able to read key events that are generated outside of your sandbox. So while you might be able to find out someone hit a key, you might not be able to find out what key they hit depending on the context. And that's another interesting point about this security system. It's context aware. It's going to make its decisions while your code is running and analyze the whole environment to make a security decision.
So, Scott, we're halfway through our talk. How about we show us something fun now?
Cool. Let me just quickly find. Whoop, no, we did Chrome. I should close these when I'm done, but I know it's an IE. Here we go. Here we go. This is kind of a fun little story. I'll say it really fast because I'm going to start cutting close on time. 15 years ago, the first demo that we did to kind of show off DHTML was this little Tetris clone I made. We called it DHTML Tris. 15 years later, I would argue that type of game is still a lot of fun. So I dug up that code that I wrote 13 years ago, made a few tweaks to make it a little more standards compliant, and then decided, let's see what happens if we drop it in our sandbox. And you'll notice that I could sit here and play Tetris really quick, and so on.
Okay.
All right.
And by the way, this is not the only game that we have available in the sandbox. There are others.
And the other thing I'm going to quickly do, and this is back to the multi-instancing. I'm going to clone the game. Now, what's interesting here is I wrote this code, what did I say, 13 years ago. This whole concept of sandboxes, virtual multiple instancing, and so on did not exist. So this code has no knowledge that it was ever going to be instantiated multiple times. I could get 2 instances of this game running side by side, no collisions. They don't even know each other's there. So the point here is that we can bring this down to the environment that you need. The other challenge that we start running into, and we saw this with web gadgets, is, well, games are this popular thing people want to build. And what starts happening is, and I'll explain what I just did in a moment, is over time you might build a page with lots of components on it. Well, at some point we run into basically the limit. The browser's just going to get bogged down. There's too many things animating. What do you do if you visit a portal site and you have 20 gadgets on it and something is eating too much processing? Well, today, typically the user has to sit there and go, uh-oh, something's wrong. I have to start guessing. And they'll just start randomly removing things that they really wanted until the browser gets responsive again. Well, what we've done is built into the system the ability to freeze any piece of code. So when I hit pause, you'll notice the game down here is still running. I'm slowly losing. I could pause this guy, come back up here, resume, and this guy leaves off just where he starts up just where he left off. The developer, my original version of Tetris had a built-in P key. I implemented pause manually. Now no one has to implement pause. We can do this automatically on behalf of any code in the sandbox. We can freeze it, retain its state, and have it continue as if it never stopped. So why is quality of service hard? I have a fun little story here. Think back to that site meter example where a line of code changed and 20+ thousand websites were brought down. Most of you run major websites. All of you know somewhere in your organization there's someone holding that pager. When your site goes down, they're supposed to run in at all hours of the night and go fix it. That error did not cause one pager to go off. Why? What are those tools doing? What is monitoring your 5.9 uptime? It's typically something that is monitoring the heartbeat of your server, saying, is the page there? Is the page there? Oh, page is not there. Send the page alert. A little simplified, but that's kind of what most of those tools are doing. The problem with that site meter example and the problem with mashups is this is client code. So when all those users failed to see the site, until someone read their email or logged in the morning and visited the site in IE, because it was only impacting IE users, they may have never known that their site was down. That's really not a good thing to happen. So quality of service was hard for a number of reasons. We pointed out isolation. But it's even harder because you say, but I have testers. That should not happen. But remember, with mashups, you don't control all your code. That code can change at any point, at any minute of the day when you choose to include a third-party script. So you need mechanisms in the environment on the client to handle it. You get unintentional conflicts. They're changing the code. Anything could go wrong. And you get that single point of failure. So grad school, this is where we kind of have a little fun. I'm going to close browsers so I can move quicker when I need to find them. All right, we're in everything goes wrong. All right, this is where I'm a bad programmer. I'm going to make lots of mistakes right now. The first things first, let me remove what's on it. I think this is pretty obvious what's wrong. I'm going to create an infinite loop. Now, what's interesting is infinite loops will eventually cause IE to prompt the user, and most browsers to say, something is happening. You probably should disable your code now. But when the user disables the code, they've crashed your application. So as we're building richer and richer websites, those errors are causing your site to fail. And your users don't know why, and eventually they hit F5 and hope things come back. I could disable just that piece of code on the page. Normally I have a ticking clock. I'm not going to write the code, but the clock we keep running. Now, lots of things can go wrong in lots of different ways. Oh, the other interesting thing about this, we could quickly reload the code back in place and torture ourselves one more time and then cancel it again. When I hit reload, I did not go back to the server. We just said just reinstantiate the thing as it started over again. But I'm going to have a little more fun this time. And usually when I do this one, I have the browser laugh at me. And we're going to run this one. Now this is my favorite one. Because if you're familiar with IE in most browsers, what do you do when the browser gets into an infinite set of alerts? Well, if you're my mom, you cry and call me and go, I can't seem to use the web anymore. There's this thing popping up. If you're us, we know about this really useful tool called Task Manager. We go fire up Task Manager, we kill the browser, losing all our state, we refire up the browser, pray we don't hit that site again and see this again. Well, we're smart enough to detect that something seems suspicious here. The user's been prompted a few too many times, and we can let you disable it. And boom. Again, the user shut down the code. Now, my last example, and I like to do this one, is because I usually get some wise guy in the room who says, there's lots of ways I'm going to cause you pain. And they're going to try to do it this way. If you see what I'm doing, I didn't make a tight loop on one thread that's going to prompt me. I set a timer. So I'm going to torture you slowly in 10 millisecond increments. And we're going to run this, and it's going to start laughing at me again. We configured this at 10 prompts, but you can control it. I'm a glutton for punishment. I'm going to keep having it laugh at me. And eventually we're going to discover that something is still wrong. Are you really sure you want to continue? No, we're going to stop it. The point here is that we have quality of service metrics all over the code. I will tell you right now, if you go play with us, we aren't perfect yet. We're covering the common cases. There are going to be places that we've missed, but the key things that we've made sure to address were infinite loops, annoying alerts. We address errors. If the code ever fails with an uncaught exception, we will shut down that code with no impact to the rest of the page. And those are really important. We are working on more complex operations, such as regular expressions that could be expensive, but all those aren't there yet.
And with the errors, you probably are familiar with what happens if you browse the internet with the errors turned on. You're going to get to see lots and lots of prompts running into pages that actually have errors.
So yeah, that's actually a fun experiment. I recommend this. Turn on script errors as you browse the web. It's amazing how unstable most sites actually are and how that problem is actually being ignored. So I'm going to go through this relatively quickly. As I said in the beginning, our goal is to support the good and the bad parts of the language. We believe 99% of the JavaScript language can be covered. But this is a work in process. What we forgot to emphasize at the beginning of this talk is we are not doing this as trying to push Microsoft's approach down on the community. We want to embrace the community. We need help. Our site is designed to be fully public. We want you to look at the code, interrogate, and so on. But as I said, it's a work in progress. Our HTML parser that reads that original web page and puts in the sandbox is pretty strict right now. It requires well-formed HTML. If you use the inner HTML properties and all those properties for assigning HTML strings, they need to be well-formed. Now, it's an interesting debate because according to standards, they have to be well-formed. Now, do we want to open it up for the real world or not? I would take feedback on that, but right now we require it. Document.write, We're partially there. I'll just tell you right now, our document write support's a little buggy. But we will not support document.write where you try to write code in as a string. That gets back to the 1% we don't support. We don't support arbitrary code evaluation where you like eval a big string because that didn't go through the transformation process. We do support evaluating JSON objects, including this JSON.parse method, which I believe will make it into the standards in the very near future. We have that built in across the board. The with statement. If you know what it is, forget it that you know about it. It's a horrible construct. But, as I said, our goal is to support that stuff too. I've discovered some libraries are using it, and we're going to do our best to support it, but it will come at a pretty big performance penalty. In general, there's no reason to use the with statement. The XML proxy, this is not a Sandbox issue, but we haven't deployed a proxy on our backend, so you can't make XML requests using our test bed at this point. It's just we just had a ship, we didn't get there yet. We are going to support, because we discovered a lot of libraries to better utilize the network allow dynamically loading code, where they will request a script while the page is running. We are architecturally built to support that just fine. We haven't turned it on yet. And we also don't support Silverlight or Flash yet. We have some thoughts on how we're going to do it. We just haven't done it yet. The finer print. Obviously, the system isn't purely magical. It just doesn't secure things without some other trade-offs. There is a performance hit. We will pay anywhere between 1.5 to 4, maybe sometimes a little higher, it depends on the operation, penalty over native code that runs outside the sandbox. If you look at the scenarios that we're trying to support and drive, we haven't hit any issues where this performance has really come into play. You would not build your entire site isolating every component. This is designed for third-party extensibility components, which are typically very focused. Debugging gets more challenging because you're looking at transform code when you step through it. The debugger keyword is eaten by default, but if you use debug equals true flag on any of our test pages, we will allow you to break in a debugger and we will disable our quality of service checks. The 1% limitation. We have no arbitrary code evaluation. That's why I said, you can't throw a string at us and have us evaluate it. However, eventually, once we understand the security models and the standards get defined, these problems can be addressed with native browser support. Moving on, watching time, we're doing good. Now we're going to go to Safari, because I realize we haven't done Safari yet. There's an interesting security issue on the web, especially with the history. Today, any piece of code can figure out where you visited. So I could go ask a question. I have to ask it explicitly. I could say, have you ever been to Microsoft.com? And I could get a yes or no answer. And to give you an idea, we're just going to show you kind of simply how that works. The red hyperlinks are hyperlinks we've been to. Here's a site. I don't know why anyone would ever go to it, and we're going to add it.
So you're running outside of Sandbox right
This
now.
is not in the Sandbox. I'm going to demonstrate this outside the Sandbox to illustrate how this exploit works. And then I'm going to show you what's going to happen in the Sandbox. Thank you, Dragos. As I said, I don't know why you would ever go to this site called Google, so of course it's going to show up blue. But I want to ask the question, did this guy ever go to those sites? So these are the RGB numbers that represent blue. Red. Red is 255.0.0. Take my word for it. You can write your own. You can check it out later. And 128 is blue. So any web page, you notice this is just a random page sitting on our server. Any web page in the entire world can write code that says, okay, I'm going to figure out what color it is and figure out if you've been there. Now let's take that exact same web page that you saw there. This was the code that was run. And drop it inside of our Sandbox. Again, we're going to add, let's use, as I said, we got to use, let's put Google in here. And you'll notice that it's going to render blue. So at this point, most people are like, what are you giving me here? It's blue on the screen. What's on the screen does not necessarily have to be what your code actually has access to. Watch what happens when I try to retrieve it. Even though it showed up blue, it told me it was red to the API. So we made sure that all the visited information is never leaked to the code that's running. That information is your information. It shouldn't be accessible. Now, smarter people point out very quick to me, as I said, there's a lot of smart people in the room, especially hackers. Those guys are incredible when they go look at this. They quickly point out it's not just about properties. I don't even need to use DHTML to go do this. I'm going to just make sure visited hyperlinks have a background image URL. and they're going to hit my server directly, and it'll bypass all that fancy code you've done. Well, that was an interesting problem. And unfortunately, that's when we had to address in that 1% limitation way. If you try to set the background image URL of a visited hyperlink, we're going to reject it. We're not going to let you set that property, because that property can be used to leak information and would violate the security constructs. So there are going to be places in the name of security or in the name of privacy we're going to have to lock things down a little bit more. And now Dragos is going to continue with a bigger picture on how this all works and take you through a few more of these diagrams.
All right, this is the diagram that you saw earlier. I just wanted to show it to you quickly and briefly for context, and we're going to drill into it. So we start with untrusted content that we're getting from an external site. And we're running this content through a pipeline, a transformation pipeline. And the first transformation that we're doing is transforming the HTML into JSON. And the way we do that is with an HTML parser. It builds up the parse tree and then walks the parse tree and generates JSON. Then we're going to do the same thing for CSS. And here we have a CSS parser that does the same thing. So it's going to build a parse tree. And then we have a visitor that visits the parse tree and generates JSON. And finally, we're going to package the JSON corresponding to the HTML and the JSON corresponding to the CSS into script. And the last step is going to transform all these scripts into the function that we can create multiple instances of, which is what Scott has shown earlier, which gives the ability of creating instances of the same page inside a sandbox. So we have, at the end of this transformation, our code is ready to run. Two things I want to emphasize about this transformation. Number one, this transformation happens not at runtime. So we can transform the code whenever we have it ready, and then we can push it out, and that's it. We're not incurring a penalty, a performance penalty here. Number two, because this content doesn't change, we can push it all the way out to the CDN, and it's going to be served there really fast. So we're not really incurring any performance penalty here. And number three, actually, and we show that briefly in the sandbox, transformation now can run on server side or on the client side. We have the same code base. The client side runs in serverless. So it's up to you to decide whether you want to run it on the server or in the client. So drilling right into this, we have our code that is ready to run now, and we're handing it off to a sandbox instance. We can have multiple instances on the sandbox running in a page. So all these code invocations that happened have been instrumented by our rewrite step. We're injecting this virtualization layer that consults a set of rules. So all the invocations that are going to type the objects, the type of the object that we're invoking on, are going to pass on the context that Scott alluded to earlier and pass it on to a rules engine that evaluates in runtime, and this is where the cost occurs, evaluates at runtime whether the call is allowed. So go ahead and get this this DOM element you're allowed to, deny, or whether you're supplying an alternate implementation, just like the W3C DOM API that Scott has showed in IE. And let's have another demo, and now that you understand we have a rules engine, Scott is going to show you how we can actually tweak the rules and change the behavior dynamically.
All right. To just reiterate a few of the points that Dragos made, that transformation process exists for one purpose: to allow all the execution of that code to go against our sandbox. So when that code is executing against the sandbox, like when we transform the HTML to JSON, that was done for a number of reasons. One, parsing HTML in the client is pretty expensive. So if we have some other process that can help turn it into a more efficient format, great. But once we have that more efficient format, how do we create those nodes? The system runs every invocation basically against a rules engine. So when you ask for the document property, what is actually happening underneath the hoods is we're saying, what object does the document property live off of? It lives off this thing called the window. Well, what type of object is the window? In our environment, the window represents a global object, where I'm saying global in quotes because it's your global object, not the whole pages. So we go look up in a lookup table and say, okay, there's the document. Great. Am I allowed to access it? Yes. Just give it back to the guy. Am I not allowed to access it? Throw a security exception. Or last, you know what? Maybe you could access it or maybe you can't, and I'm going to make that decision dynamically. And now I'm going to show you a very simple example. Alert. When I run this and click, right now I think we're back in Firefox, we're going to display an alert that says hello world. There might be sites out there. I know Facebook made this decision. Alert was not something they wanted to let code do directly. So even though we had protections against infinite alerts and so on, Some people find alert to be obtrusive and don't want it to be allowed in their environment. So what we're going to do here is replace the alert implementation. So jumping down onto the sandbox, I'm going to spend a few minutes just to kind of show you. You'll notice here's the alert rule for alert. The reason why it's not a simple allow is, remember, we had that quality of service layer wrapped around alert. So what we're doing is saying, while the alert is displayed, stop managing the quality of service. In other words, while the text box is up, I'm not going to take that into account in execution because the user has to confirm it. The moment the alert goes away, our quality of service layer is calculating how long things are going and so on. So that's happening automatically right now. This ugly line of code is me just re-implementing, making sure nulls render correctly, and so on. But so here's what's going to happen. As I said, the first thing that happens is we type this thing. I'm going to do an annoying scroll here. And here we go. Alert is off the global object type. So this is our lookup tables. Even though JavaScript is a dynamic language, we've typed everything in the language as it runs. And we have to do it as it runs because the language is dynamic. We don't know, we can't statically look at it up front and say that has to be a string because it can mutate at any point. So we know that on the global object, we eventually are going to see, assuming I don't scroll by it too quick.
That's it. You passed it.
I passed it. Eventually, right here, that's what I was looking for, the I. For invocations on that object, when alert's invoked, we're not going to display an alert anymore. What we're going to do is set the default status property. Now, you'll notice I didn't directly go window.defaultStatus equals the string. Why? If I did that, I would set the status of the whole window. I didn't want this message to override potentially what the outer page has done. So what I did instead was said, I'm going to set the default status in the context of the current sandbox instance. So this is saying do a set on the same object because it's on the same global object, this property, the argument that was handed in. And we're going to save this. Jump back to Firefox. I'm just copying that because I'm going to do a refresh. Paste this back in. Now, hopefully if I did this right, you'll notice I didn't get an alert. Instead, what would have been an alert showed up in my status bar. Now, if you start thinking back, I said I implemented W3C standards. I was able to enable any API I want. This model allows us to build security systems and override or deny or create any API we find necessary. So to think about this, the one piece that we never discussed, and we're going to illustrate just in the graphic because we're running type for demos, is that you got your host environment again. Your sandbox can talk out to that environment. It can expose public methods. Now, how does your code expose a method to the outer page? Well, JavaScript has a great way. If you build your own object in JavaScript, how do you expose a public method? This dot something would create a public method on an object. If you, in your global code, went this dot, we will make that function available to the surrounding environment. So it's like everything you add to your window in your own scope gets exposed outside. Follows the iframe model pretty well. The other point, which is more interesting, is remember I said think outside the box of a gadget in the beginning. Everything we've shown you here is basically focusing on W3C, standards-based programming. Let's say your page had a mapping component on it, and you wanted to let untrusted code plot a point on that map. Well, by default, our security system is going to disallow it. What you can do as a host provider is say, I'm going to build a rule for that map object. So when they try to go out to my outer environment and maybe call the map.addPoint, you could build a rule just the way I showed you for alert that says addPoint is going to safely invoke displaying a point on that map. And maybe I'll build some quality of service and limit it to maybe 5 points. The point is, no pun intended, is that everything is under the control of the host. The host can define APIs. Back to that example. If you're thinking of pure extensibility, let's say you want to build a non-UI component. Everything I showed you here is visual because it makes a better demo. What if you wanted to let people write JavaScript that only augmented business logic on the page? So let's say you had a data bus that you wanted to communicate with, but you didn't want to let them render anything directly. You could say, no, I'm going to give them the JavaScript policy, which will give them the capability to write JavaScript, and only the capability that it gives them that explicit rule to access those APIs, and disallow access to rendering. All this is, again, under the control of the host. Now, we don't have, ooh, the yellow didn't really work. I'll explain what that unreadable yellow thing is. How easy it is to consume the sandbox on your page. This is blue. We were told the blue slide meant future. This is basically how we do it. We just don't publish the sandbox in a consumable way like this yet. But you basically put your untrusted content with a div. This is how the gadget policy works. So I have a div ID put content here. I load the sandbox script. The sandbox virtual machine is written entirely in JavaScript. That's how we were able to run in all browsers. And the key thing there was no install. It just runs. The next thing we had to do was say, go get that untrusted content. We don't load, in the SiteMeter example, you remember went directly to SiteMeter's site to get the code. In the sandbox, you would ask for it via a transformation engine. So we would go to our web sandbox code organization, go to transform.aspx. The yellow is supposed to be that URL to the untrusted code. And we would give it a GUID, a unique ID. The host would specify a GUID. Then the next line of code is merely saying, create a sandbox for that particular ID. The policy.gadget says apply to gadget policy. You can define any policy you want. And give it the GUID of the code that it was represented. And we will just fire one of those instances up. And you could do this as many times as you want. You'll notice the code was only loaded once. And you can new this thing up 1 to 10 times, any number of times you want. We're running a little tight on time because I want to leave 15 minutes for Q&A. This was not that exciting of a demo. So what I'll explain it was, because I know you all know how to browse the internet. We were going to show you the web sandbox site. On the site, a few things I just want to point out. You could do it while I'm talking. On the site, the sandbox that you saw us running in for all our samples is the test bed that we have on our site. So you can go into our site, try typing any HTML you want. You could provide a third-party URL, but remember that third-party URL has to be well-formed HTML. We've discovered people try entering every website that they know of, and it fails because we've discovered most people don't write well-formed HTML on the web.
So to quickly explain here, there's documentation, and all the documentation is interactive. You can fire up the various parts. So all the samples, they have a run the sandbox, and they're just going to fire up a new window, and you can run the code in the sandbox. Another way of interacting with the site is through the samples that we have provided. So these are samples, challenges to developers, if you will, that we provided. And your mission would be to try to compromise the sample. So this sample just shows the clock, and then you can inject your code here and try to compromise the sample.
To be explicit, that example is showing a ticking clock for a reason. Under no circumstances should you be able to inject code in that sandbox that causes that clock to stop, to change, or morph other than be a ticking clock. Because if you did that, you basically walked outside of the isolation mechanism. So throwing errors, finding a way to get the alert to occur, finding a way to kill that clock. If that happens, we want to know.
And then the last way is to just write a gadget if you don't care for our code and you just want to inject your code. This is where you toggle between the client-side transformation and the server-based transformation. And last but not least, we have community forums here for discussion. So with that.
The one point I want to make on the forums, the bottom one is the most important one. Right now, we are a preview technology. We want the community to get involved, and we want all of you to basically look at this and help us. But what's interesting is we have the full disclosure form. It's not moderated right now. There's no reason to moderate it. This is a technology preview. We want exploits discussed openly in the community. What I didn't point out, which was quite interesting when I made the comment about community involvement, the first day we released this, the first 2 exploits that were mailed to me directly just because I know the people that were involved, the first one came from some friends in Yahoo, and the second one came from some friends at Facebook. So this, as I said, this is not something that I think any of us in the industry are going to look at in isolation. We know we need to address this, and we do want to work together, but it's more than just us as the companies involved, it's the community as a whole. We invite you to come work with us. It's an open project. One of the pages is, right now, because I'm sure I'll be asked, We are exploring the appropriate open license to use. We want your feedback. Which was the best license to help engage the community? The code is visible. The Sandbox client code, you could go interrogate it. With the debug flag, you will not get the minimized code, so you can actually go look at exactly how it's written and tweak it and so on. And again, just join us and help us make this work right. And I think we're ready for a Q&A.
All right. Thank you.
Thank you. I think there's mics up. There's 2 mics if there's any questions. And the other point I'll just point out up front, depending on how the questions go, if people want to do a deep dive, we'll find a time, just come up at the end, and we'll make sure to meet in the lounge. We'd be happy to walk people directly through any of the code at any level of detail you desire. It's just there's a limit to what we can do on stage. Yes? The question is, when do we expect it to be available hosting in your own site? As soon as possible. The first thing we need to address will be the licensing. The other thing I will just give a heads up for the hosting in your own site. I put the word preview in front of it intentionally. I would not claim we're at production quality for, I mean, it's better than, I guess, having no security, but we're not going to make claims that we've actually got it 100% right yet. But our intent is as soon as possible. There's a person, I think, right back there. Yes? That's a great question. How big is the footprint of the JavaScript library? Right now, I will talk in gzip numbers because I think that's what we care about, because if you're not compressing your code, you should be. We're sitting at about 25K gzipped. Now, keep in mind, that includes all the default policies. As we work through this, I don't expect us to grow much. We probably won't shrink much, but my target really is to drop us down to about 20 when we're done. My belief is anything larger than 30 is going to just be too big. The other thing to keep in mind, if done right, we can edge cache this and all share it from one destination, so it really shouldn't be a huge perf hit for the download. Right there.
Right. What's your goal for performance improvement? You showed the 1.5 to 4 minutes. How much do you plan to bring that down, or what do you think?
The question is the performance overhead. The performance overhead is going to hit the theoretical limit of what we can do in the browser. We're noticing some browsers are faster than others, but the performance overhead seems to be constant across them, so they all start at a similar baseline. We have some optimizations. We do know we could get faster than we are today. There is a benchmark page in the documentation at the bottom of the processing documentation. What that benchmark does is provide you the raw overhead of a call. It doesn't take into account of actually doing anything, so you can get a feel for it. We expect to get quite a bit faster than what you see there, but we do know, I believe the 1.5 to 4 is going to survive no matter what we do. It's basically we're recognizing the stuff that's closer to the 4 to 8 times that pops up now and then. That's the unoptimized code. It's harder to get rid of the 1.5. Just so you know, though, the long-term goal will be once we all get an agreed-upon approach, we get a standard, eventually this is the type of technology that can be built into the browser with no overhead. We know it's possible. The reason why we have the overhead is we're a JavaScript library. Yes?
What will be the limitations for inter-gadget communication? If you have 2 gadgets, 2 separate sandboxes, will they be able to communicate, or are there limitations?
The question is there any limitations between inter-gadget communication? First things, we haven't built the true inter-gadget communication architecture yet, so it's something I want to get a better feel with. It's actually an interesting problem, and I'll explain quickly why. First, inter-gadget communication is as flexible as the host wants to make it if they want to provide their own custom rules. So they could build a rule to make it as rich as they want, where the host acts as an intermediary. One of the things we did institute at this point, until we feel more comfortable, is all messaging that goes from the host environment into a gadget has to send a primitive type. It can't send a function pointer. So if you want to send a rich object, you would serialize it to JSON. Our concern is basically leakage. If someone from an untrusted environment handed us an untrusted function, it might be directly invocable. I've had some discussions with people in the industry. We don't believe we have to live with that restriction, but it's one I'm imposing at this point just to, I'd rather be conservative in this case. Security is one of those things I've also discovered. If you open it up too much, You create more pain closing it later, where if I can take a more conservative approach on certain things I'm not 100% confident about, no one's going to argue if I make the environment richer. I don't see anyone getting upset if later on and I say, now you can hand anything you want. So I'm going to take some baby steps there. Did that answer your question? Okay.
We have time for one more question.
Yes. What was the question? The question was sandboxing event handlers from Flash or Silverlight. My answer is again more in our research phase at this point. One of our plans there is for Flash. We're going to intermediate any requests that go out to the outer page through a proxy object. So the way we'll secure, by default, unless we do something within Flash internally, we can't secure what's executing within Flash. But our plan is to guarantee if Flash wants to reach out to the outer environment, it's in the same sandbox as the code that creates it. And our plan is to do the same thing for Flash and for Silverlight in that regard. The real harder question is what can we do to make sure that stuff executing within Flash stays secure? If anyone here is from Adobe, I'd be happy to have that conversation offline. It's one of those, it's basically take a similar architecture that we've done here and bake it directly in the Flash. We're also going to be standing up here if you have a question you don't want to get up on a mic or anything, and we could continue to take them. Dragos and I are here all week. Feel free to grab us if you have any other questions. And as I said, this is something we want to be very open and transparent about. So we're very happy to sit down on our machines, fire up the code, and walk you through things in a lot more detail if you desire.
All right.
Thanks.
Thank you very much.